Okay guys, we're back for day 2. So hopefully the substitution work that you did Monday, Tuesday went okay. I'm going to review just one question from that, just because substitution can be a topic that's a little bit trickier for some. So I'll just go over one question, and then today we're going to be going into solving one-step equations. Okay, so let's say for example we have x is equal to -3 and y is equal to 1. Okay, and I'll just do one example from that. So let's say I have x times y on the top divided by x plus y on the bottom. Okay, so we're going to start by substituting in. So on the top, I've got brackets for the x, brackets for the y. So what goes in on the top, x is -3, okay, and y is 1. So that's the top. So the top I have -3 times 1. On the bottom, I have brackets plus brackets, so x plus y. So I've got -3 for x and 1 for y. Okay, remember the hint that I gave you yesterday is that when you have a situation that there's division like this, you're going to solve the top all the way down to getting one number, solve the bottom to getting one number, and then you divide. Okay, so the top, I have -3 times 1, so that is -3. So I've got -3 on the top. On the bottom, I have -3 plus 1, so that is -2. So my question just becomes -3 divided by -2. Okay, so we know a negative divided by a negative is going to give us a positive answer. So you can write that. And 3 divided by 2. You could either leave that as a fraction, okay, or you could write 1.5. Okay, 1.5. Okay, so just a quick review from yesterday. We're going to get into now today's work. Okay, so today's work is all about solving one-step equations. Okay, and then next week we'll be getting into solving two-step equations, but today we're going to start with one steps. Okay, first of all, a little definition. So an equation, what is an equation? An equation is a mathematical sentence that says two things are equal. Two things are equal. Okay, and usually it includes numbers and variables. Okay, so for example, you know, this would be an equation. X plus 7 equals 10. Okay, that's just an example. Now, what we're going to be getting into is to solve them. So to solve an equation, you basically are going to be figuring out what's the number that x represents, or whatever variable you have, what's the number that x represents in order to make this mathematical equation make sense. Okay, so we know in this case x would be 3 because 3 plus 7 equals 10. You're going to be making both sides of the equal sign equal to each other. Okay, so to solve an equation, it means to find out what number the letter represents, the variable, I'll write the variable. The variable represents for the equation to work. For the equation to work. Okay, so just some definitions for you. Now we're going to be getting into solving the equations. So there's two methods. Okay, so you can always pause that if you want to write that down. So there's two methods we're going to go over. And the first method is very, very simple. So method one is solving by inspection. So basically, you just know what the answer is, okay? So for example, let's say we have 3x equals 15. Solving by inspection is just looking at and saying, okay, 3 times what? So 3 times what gives you 15? X equals 5. Okay? So all you're doing is just saying, oh, I know that x has to be equal 5 because 3 times 5 is 15, and we can right away say that x equals 5. Okay? So that's solving by inspection. A lot of the questions that you will have on your sheet, and for today, you can do by solving by inspection, but I do want you to give a try to the second method. It seems very simple to do for some of the questions that you will have today, but you really need to get the second method down in order for next week's lesson of two-step equations to make sense, okay? So method number 2 is reverse operations. Okay, so reverse operations, I'm just going to give you a list of what they are, okay? And most of these are very, very intuitive. So the operation and then the reverse operation. Okay, operation being, if you are adding, okay, to do the reverse of that, you are going to subtract. If you are subtracting, okay, to do the reverse of that, you add. Multiply, you're going to divide to do the reverse. Okay, and if you're dividing, you're going to do the opposite, you're going to multiply. And if something is positive, okay, when you do the reverse of it, it turns into negative. Okay, if you can just keep that in mind or copy it down on your sheet that you're making notes on, that will start to make sense when we do some examples. Okay, but first we just have to know what the reverse operation is for each operation. Okay, so let's do a couple of examples using reverse operation method. Okay, so question number 1 is x plus 5 equals 12. So it's pretty simple. You probably could solve for x right away using the inspection method, but try the reverse because like I said, next week when you're doing 2 steps, it'll be a lot easier if you understand how to use the reverse operation method. Okay, so you ask yourself, you say, okay, here I'm adding. So what's going to happen is this 5 is going to move over to the other side. Okay, when it moves from one side of the equal sign, so it's currently on the left, it's moving over to the right so that we can have x on its own, okay? Because we want to know what x is. We can't know what x is if it's mixed in with some numbers. So we put the numbers on the number side, we keep the variable on the variable side, okay? So when the 5 moves over to the other side of the equal sign, you do a reverse operation. So here it's being added. So when you bring it over to the other side, 12 is not switching sides, so it does not change at all, okay? But the 5 is, so it's being added here, it gets subtracted. Okay, that's the reverse operation. So x equals 7. Okay, let's do another example. X minus 5 equals negative 77. Okay, so again, we want the x isolated. We want it on the side on its own, so we can say x equals something. Okay, so that means that this number, 5 needs to move over to the other side. When it goes from one side of the equal sign to the other side of the equal sign, the sign changes. So this operation of subtraction becomes addition on the other side. So this would be negative 77 plus 5. Okay, so x is going to be equal to negative 72. Okay, let's do an example with multiplication. Okay, if you're feeling like you can try this reverse operation, pause it, give it a try, and then check your answer. Okay, so we know we want to have x on its own, so we can say x equals something. Because you say, okay, what's the operation happening between the 3 and the x? When the 3 moves over, do it in red like the other ones, when the 3 moves over, it's going to do the opposite of what it was doing on this side. Well, here it's being multiplied, so when it comes over here, it's going to be dividing. Okay, so and that's going to go to the bottom. Okay, because it's 3 times. Now it's going to be this divided by 3. Okay, and that's 7. X equals 7. Okay. What else do I have for you guys to try? Let's do x divided by 3 equals 2. So you might be able to do it by inspection, but again, give the reverse operation a try. Okay, so the 3 needs to move over so the x can be on its own. Here, the operation is division. So when the 3 moves over to this side, it's going to be the reverse operation. It's going to be multiplication. Okay, so x is going to be equal to 2 times 3, so x is equal to 6. Okay, now because we've already substituted, you can check every single answer and you would know if you got it right or not. Because if 6, which is x, gets substituted in here, it'd be 6 divided by 3, and then that's 2. So 2 equals 2. That makes that statement correct. Okay. So I will just do a couple more examples, more just so you can check that you are on the right track. Okay, make sure you're pausing every time, giving the question a try, and then checking your answer. So let's do this one. Negative 3 plus y equals 8. Okay, so this is kind of the situation where you have a negative on this side, and the negative 3 is going to move over to the other side. So if it's negative on this side, it's going to turn to positive on the other side when you use the reverse operations. So y is going to be equal to 8 plus 3, y equals 11. Okay, again, if you took 11 and you substituted it back in for y, you'd have negative 3 plus 11, which is 8. So 8 equals 8, and that's true. So then I know that I did that question correct. Okay, so I think the last one I will do is x divided by negative 2 equals negative 5. Okay, so try it on your own. Pause the video. 2 is being divided by on this side, so it means it's going to be multiplied on that side. Okay, so x equals negative 5. When that comes over, it's going to be multiplied. So times, you can write it by times negative 2, or you could write it negative 5 times negative 2, like that. Okay? Either way, we have a negative times a negative, which is positive, and 5 times 2, that's 10. Okay, so your answer should be 10. Okay, so you'll have a 2-page handout here. The first page has a whole bunch of questions having to do with reverse operations, adding and subtracting, and then the second page is the addition, or the multiplying and dividing. Okay, so it gives you lots of questions to try, and please make sure you're trying to do it with the reverse operation just so you're ready for next week's lesson. Okay.